I think the first two are probably pretty easy. Didn't print properly, so it was missing a u. This one's obviously cos u times u prime. And this one is negative sine u times u prime. We've seen tan a little bit. Who remembers tan? Close. So, sorry, yes, no, that's right. What was I thinking? Secant squared. Yeah, u times u prime. Sorry, I had cosecant on my brain, so I was thinking cosecant. But you're right, it's secant squared. Very good. And then cotangent.
Negative cosecant squared.
Yeah. U times u prime. So we haven't seen that one. A lot of questions today are cotangent for whatever reason. And then we only did this as like just we explored how to do secant as a reciprocal function. So we've seen it, but we haven't actually used it. But does anybody remember what it is? Good. And so then that makes cosecant. You can use the patterns to memorize these. Because cosecant goes with cotangent, and secant goes with tan. So secant and tan, secant tan, and these ones are always negative. So this one's negative cosecant u times cotangent u times u prime. But now these are ones that we need to know. So nothing else that we're doing today is, oh, I missed a question already. Nothing else that we're doing today is new. It's just applying these sort of for the first time. So give this one a try. It's pretty simple, pretty straightforward. So secant u, tan u times u prime, the derivative of the angle, which is just a half. And definitely the rule is we would combine those monomials. So 16 times a half is 8. You can try this one too. I could imagine that somebody might misread this and think that it's y equals cosecant root x all to the 5 because of the notation of where we put exponents, but that's not what this question means. If you're ever unsure on a test, ask and I'll tell you, because it's not about interpreting the way that the computer writes the text, right? But this is supposed to be the 5th root of x, just so you know. So negative cosecant u, cotangent u, u doesn't change. Now I multiply by derivative of the angle, 1 over 5 x to the negative 4 over 5, subtracting 1. And again, typically we clean up negative exponents. So I'd rewrite this as negative cosecant cotan over 5 fifth root of x to the 4th. This one's a little bit more challenging because it's got everything. So exponent, trig, angle. Remember to say those in your head when you're doing these. Exponent, trig, angle. And just be really mindful. Like it's really, these ones have all these parts. It's easy to miss one little part. So I'm going to start with exponent. Nothing else changes. Just drop the exponent by 1. Now the trig part. Derivative of cosecant. So negative cosecant, and again, I think people think it's still squared or still cubed, but it's just cosecant to the 1. We've already done the exponent. Okay. And then the angle. And I've got a negative, a 6x, and a 3, so those are all going to come out front. And I've got cosecant squared 3x squared and another cosecant of 3x squared. So that's going to turn into cosecant cubed 3x squared cotangent 3x squared. Don't get too caught up in exactly how you should simplify, but I think that would be expected. Just like if you have a couple of x's, you'd make them x squared, right? Same idea. But in terms of taking this any further or anything like that, we don't typically for these. We okay? Same thing, this one has exponent, trig, angle. So you give it a try. Challenging part of this one is when I do go to take the derivative of the angle, it's got chain rule as well. Power of a function, right? Because it's 3x plus 1 all to the 5th. So it's going to be 5 times 3x plus 1 to the 4th times the derivative of what's inside, which is 3. So let's see, I've got a 4, a 5, and a 3. So 4 times 15 is 60, so negative 60. I feel like usually we would put this next, but that's not necessary. Okay. Uh-oh. I'm really mucking with stuff here. Let's just leave it for now. Okay, and then what do I have left? I've already got the negative, so cos, oops, cosecant squared 3x plus 1 to the 5th. I think that's everything. Oh, no, I'm missing something. Cotangent. Cubed. There we go. Okay. Oh. What do we have to watch for this one? It's product rule. Okay, so derivative of the first times the second plus derivative of the second times the first. Not too much we can do here. You could factor out an x squared, but I mean, that's not, generally speaking, we don't try to factor these unless we're doing something with them, like solving or something like that. Everybody okay with that one? So this one I think is a bit more obvious. It's quotient rule. Hopefully, give that one a try. So again, so this is derivative of the top. If it wasn't color coded, it'd be a little bit hard to follow like what came from where, right? But derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. And then I can clean this up. Negative cosecant cubed x plus cosecant x cotangent squared x. And I also noticed that I have a common factor of cosecant on both. So I could take this a little bit further. Generally speaking, I would say if it's as easy as that, I would do it. If it was a lot more work for whatever reason to get it to factor and cancel out, then I wouldn't. But again, don't get caught up too much in what form or like how far you have to simplify. That good? Yes?
I'm lost with the negative sign on the top, so negative cosecant squared x times cosecant x minus. So how did it become plus?
These two negatives become plus.
These two negatives?
This is a negative here.
Oh.
Right? That?
Oh, minus. Oh, yeah, okay.
That's not true. Or could we have done it this way? If y is cotangent x times cosecant x, that's like cos x over sine x, because it's the reciprocal of tan, and times 1 over cosecant. What's 1 over cosecant? What's 1 over cosecant? Sine? Which way is easier? Block A class said the first way because they just wouldn't have thought to do that. I wouldn't have either. I wouldn't expect you to do that, but if you did, I'd be like, hey, good on you. And you'd get full marks for that. It'd be fine. Again, that's just like all that work that we do with identities. People think, what's the point of all that? Actually, there is a point because you can simplify things and make them a lot simpler in some cases. If you were solving this to do a first derivative chart, I'd rather have the second form than this one. I don't know what you would do with that to try to solve it. But that's not something that we would put a question on a test to expect you to get that, I don't think. So don't. It's just interesting when it happens. Any questions? Okay, we got a couple more. Implicit. Like I said, we've already done implicit. It's not new. We're just applying it in a bit of a new area. This one's very straightforward. So go ahead and do it. I don't think you need to copy me. So here's the derivative of cosecant 5y times the derivative of the angle. What's the derivative of the angle?
Yeah, dy by dx.
Good. Don't forget the dy by dx's. I suppose it's a little tricky when you're doing trig and it's in an angle or something like that, and you just might forget it, right? And this one's pretty easy to rearrange. I just divide by everything else. So I end up with dy by dx equals negative 4 cos 4x over 5 cosecant 5y cotangent 5y. Okay. Last one. Now, when I go to do the derivative of, the angle for this one, what do I have to be careful of? I'm going to redo that. So cosecant squared 4xy. Yep. It's product rule again. Because there's so many levels to this, it's easy to miss that. So 4x times y is product rule. Derivative, so it's derivative of the first thing times the second thing plus derivative of the second thing, which is just dy by dx, times the first thing. And then we're going to have to do a little bit of work to expand this stuff out. Equals 0, by the way. That's a bit better. Cosecant squared. And again, I see that there's a common factor of 2 in everything here, so I could take this one step further. But this doesn't really help much. Like in terms of solving, if we were doing anything with this, it really doesn't help much. But if you notice it, it's not bad. Any questions? Okay, so the worksheet that was posted, those are the ones we want you to do. Just the left column of the worksheet, all of 2, 3AD, 4AB. Question 4 is, I think, a first derivative chart. And question 3, I can't remember now what it is. But there's at least one of the other 2 that are in 4. Like you can do all of it if you want more practice. All of question 1 is fine. All the solutions will be posted, and I think the answers and solutions to all of them are there. So all of question 1 is good practice, and the other 2 and 3 are fine. At least one of the other ones in 4 is a little bit hard, a little bit long. So just be mindful that if you do C and D in 4, that one of them, I can't remember which it is, has a lot. Like it's got a big chart kind of thing. So solving is a little bit challenging. Good practice though. And then there's a challenge question, question number 5, optional, but it's a nice little question, fairly straightforward in some ways, but it's would be an interesting one to check out if you like. Okay. Any questions? Yeah. I don't know for sure. We